Welcome to WebHack, and as usual, we move to online. But before that, we are very active offline event, basically hold every month, and we like to visit the different companies' office and open space to provide different experience. But unfortunately, because of COVID, we hope everyone can keep safe, so we move to online, and we have YouTube channel as well. So. Like today's event, we will have the video online, maybe, depends on whether we respect the speaker and everyone's opinion. So, but anyway, there are still a lot of things we want to share. So the channel will sometimes get a new event records. And we also have a clubhouse. If you feel interested about that, you can ask a people or just search the keyword later. So anyway, we had a success past, but we hope we can have another kind of success online event. So that's what we are trying. And if you feel interested to share anything, you can just fill this form, and literally anything, but better to be connected with tech, because our audience usually have the big tech background. But we also welcome like a management or like a project progress or something experience to share anyway. And we have a hack ND, but unfortunately this thing is kind of, well, now it's kind of with a problem, so we're fixing that. We may share in the chat later. So today's agenda is just with one speaker, one session, and Julian will talk about his project, his work, and the Scala language. So yeah. And please just spend some time to also feel our feedback, because we actually discuss your opinions every time, and for every opinion we try to make some changes, so that's important to us. We will share the slide after the event on the event page. And now I will transfer to Julian.
Yep, let me share my screen. 2 seconds. Yeah, does it work? Can you see it?
Yes.
Awesome. Let me make it bigger. Okay, probably don't need this. Cool. So hi, everyone, and thank you for being here today. In this presentation, I would like to talk about optics. So optics are often described as being the equivalent of jQuery or JSON path, but for all immutable data. So, with such an impressive comparison, you would expect optics to be very popular, right? Well, this is the case in Haskell, but in Scala, we rarely see optics in real-world code bases. Why is that? Why are optics not popular in Scala? Today, I want not only to answer this question, but also offer some solutions to the current problems. So let me quickly introduce myself. My name is Julien Truffaut. I'm a Scala backend developer, and I also teach functional Scala at fptower.com. I recently released an online course that focuses on the practical side of functional programming. And if I have time, I would like to say a few words about this project at the end of this talk. Now, the most relevant aspect for today's presentation is that I'm the creator and one of the maintainers of the open source library Monocle, which implements optics in Scala, and it's part of the type-level ecosystem. So it's a set of libraries in Scala that is around functional programming. Okay, so for today, I have two objectives. First, I want you to understand what optics are and which problems they solve, so that you will know how to use optics in your own code base. Second, I want to present the existing shortcomings with the Monocle API and how we plan on addressing them in Monocle 3. So Monocle 3 is a new major version of Monocle that's going to be released in the coming weeks. Does that make sense? By the way, don't hesitate to interrupt me at any time during this talk if you have any questions. And this talk, normally you should be able to follow it, most of it at least, if you don't know anything about Scala or optics. But really, don't hesitate. We're a small group. Don't hesitate to ask any questions. I'm more than happy to explain the slides in more details. Okay, so the first question for today is, what do we need optics for? I don't know about you, but when I learned programming in languages like C or Java, pretty much all data structures were mutable. And we can replicate the same behavior in Scala by creating a couple of case classes. So a case class, I don't know if you're familiar with the term, a case class is basically a class, like in Java, it's an object. And when you use this case keyword in front, it really transforms it. Normally, it makes all the fields immutable. So it's perfect to encode data. Now, it's possible if you want, it's very rare, but it's possible to add a var keyword in front of each variable. And in this case, instead of making the variable immutable, it makes it mutable. Now, the benefit of this is that we can simulate basically the behavior you would get in Java by default, for example. So for example, let's say I create a user called Julian. And so this user, this is how I create it. I say, okay, his name is Julian. His address is 12. So 12 is a street number. And E164SR is the postcode. This is the kind of postcode you get in the UK. So the nice thing about objects is that you can use the dot syntax to drill down inside the object. So you can say julian.address.street-number, and this will give you the number 12. It will give you access to the street number field. Now, I think everyone should be roughly familiar with this syntax. Now, the nice thing about using variable in the case class is that you can as easily modify the object. So you will say julian.address.street-number equals 16, and this will mutate the object, setting the number 16 inside of this user. So I would say, it's fairly convenient, fairly simple to understand. This is the kind of things we get, in almost all programming languages or something similar, right? So if this is convenient, what are we trying to fix? What is the problem here? Well, the problem is that in FP, we mostly use immutable data. And I will quickly go through the main reasons for that choice. So the good thing about immutable data is that it offers some nice features like versioning or the possibility to roll back, since we never destroy or erase anything. The data is there and it's there forever. For the same reason, immutable data simplify testing because we can take an object, apply a few transformations, and then compare it at the end with the initial state. The initial state is still there, is still available, and hasn't been altered in any way. So we can check, what did we change exactly? Finally, and most importantly, in a concurrent environment, it's extremely difficult to work with shared mutable data. Either it leads to race conditions, meaning that some threads can access a program in an inconsistent state, resulting in some very tricky bugs. Or we get deadlocks where nothing gets done because all threads are waiting on each other. While it is theoretically possible to avoid these issues, it's notoriously difficult in practice. I recently watched an interview with Mozilla's Jim Blandy, co-author of Programming Rust. In the interview, Jim mentioned that an engineer at Mozilla decided to use a thread sanitizer tool to look for data races in their C++ code base. And he found that in every case where Firefox used threads, there were data races. So not just some or most cases, but every single case. Those bugs were eventually fixed, but it illustrates how difficult it is to deal with shared mutable data. So if we agree that we should use immutable data structure, there is still one big question that remains. How do we change them? Because at the end of the day, we need to make changes in our applications. For example, when we receive a salary, we expect that the software that runs our bank account to increase the balance, right? Not everything is immutable in the world. So how do we change something that by definition cannot be changed? So here I have a short story to illustrate this situation. So imagine you're a programmer in an immutable world, and you're at your desk, you're sitting at your desk while you realize that the light bulb is broken. How do you change it? Normally in a normal world, you will just, unscrew the light bulb and put in a new one, right? But you can't do it because the world is immutable. Putting in a new light bulb is a mutation. So you're a clever functional developer, so you have an idea. Let's do something simple. Let's create a new planet, from scratch, something, just a new planet, a bare bone planet. And what we're going to do is that we're going to copy over every single continent, forests, mountains, oceans, everything. Every city's building. Within each building, we're going to copy over every room, every item of furniture, even the lamp. But the only thing that we don't copy over is the light bulb. So in this new world that we just created, we put in a new light bulb, and that's it. This is the only modification that we make. Easy peasy, right? When I heard this story for the first time, I thought it was a joke. Why on earth would you go through so much trouble for such a tiny modification? Well, it turns out that most of the time, we don't manipulate such a large immutable object. And even if we do, it's not that expensive to create a copy because we can reuse most of the data that hasn't been changed. It's safe to share that data because it is immutable. In addition, we don't need to recreate a new version of the entire object for each modification. Instead, we can keep the old version and accumulate the changes, on the side. Then once in a while, we can apply all the changes in one go and recreate, like if you want, a new snapshot. So to summarize, even though immutability seems to be extremely inefficient, it actually offers decent performance, and it saves us a lot of troubles caused by mutability. So that's why I think it's a great trade-off. By the way, I would like to thank ImpurePix, the person who made these drawings. And I encourage you to check out his website, impurepix.com, where you can find lots of FP-related infographics that are both funny and really instructive. Okay, so do you have any questions so far, or does it make sense? Kind of? Okay, so the idea now is that now that we agree that we need to copy objects in order to mutate them, how do we copy objects in Scala? So how do we apply this idea to the Scala programming language or whatever programming language you're familiar with? So this is where I have 3 examples that are very simple. I'm pretty sure these examples, you have them in your own code base. And the goal is to see how can we do it using the vanilla Scala, just the bare bones Scala language. And then we'll introduce optics to these problems and see how can they help us in this situation. So the first exercise, the first example is we go back to our example with a user and an address, except that this time all these fields are immutable. There is no var keyword in front of each field. Now, so the same question is, how do we change the street number inside of this user now that the user is immutable? Well, how we do this is actually quite simple in Scala. We can use the method copy. So by default, the Scala compiler, when it sees a case class, so it has to be a case class, it adds a method copy automatically. That when the method copy, you just specify which field do you want to change. So here I say, here is Julian. Julian is my user. I want to change the address. So I say I want to copy the original user, and this is what I want to change. And everything else stays the same. So you could potentially change several things at the same time, but here I only want to change one. And then you say, okay, how do I want to change the address? Well, I take the original address, julian.address, and I copy it again, and I want to change the street number. So if you want, you take the original address, you change the street number, and you set the new address inside of a copy of the user. So it's not the most short syntax. It's not as good as we had when we were using mutation, but it's not that bad. If this was the only use case that we had, then I would say copy is great. We don't need to look further. We don't need something more complex than that. However, the real problem is that our data is not only case classes. For example, one thing we have quite often is an enumeration. So here I use I don't know if you're familiar, this is a new syntax from Scala 3 for enumeration. There is another syntax in Scala 2, but it's much more verbose. So imagine we have an enumeration called payment method. So payment method describe how can you pay, how can a user pay us in a website. So they have two options. They can either have a PayPal account or they can have a debit card. So if you want, they can't have both, they must have one or the other. And a PayPal account is just an email address, and a debit card is like a card number, an expiration date, and a security code, the kind of details we always enter in kind of any website. Now imagine we change our user and we say, okay, a user is now a name, an address, but also a payment method. So we say, for example, Julian has this address, and it has a debit card with these particular details. By the way, don't do any screenshot. This is not my real debit card. You can't use it. And imagine we have another user, Anna, that is the same. It has a name, an address, but this time has a PayPal account. Now imagine, so now the question is, how do you change the expiry date? So how do you change this field inside of a user using, again, Scala, the bare-bones Scala language? So I suggest that we start exactly like what we did before. Let's use the copy method. So let's write a function. So let's say, okay, this is a function called update expiry that takes a user and a new expiry date. So we want to basically insert this new expiry inside of this user. So what we do is that we say, okay, let's do user.copy. We say, what do we want to change? We want to change the payment method. So we take the current payment method and we call again copy and set the expiration date. Fairly simple, right? However, it doesn't work because, and the Scala compiler will tell us so there will be a compiler error. And the compiler will say, okay, there is no method copy for payment method. And that makes sense because payment method, if we come back a couple of slides ago, payment method is an enumeration. It's not a case class. And it's normal because if you want, what if this payment method is a PayPal account? We can't change the expiration date inside of a PayPal account. It doesn't have an expiration date. Okay, so the generic question is, how do we modify an enumeration? So in Scala, we have something called pattern match, which is kind of like like an advanced switch keyword. So what you can do with a pattern match, you can say, okay, let's look up the payment method and differentiate based on the two cases. We can say there is one case where the payment method is a debit card, and another case where the payment method is a PayPal account. Now, once we do this kind of switch statement, it's quite easy to solve the problem. We can say, okay, if it is a debit card is a case class, so we can call the copy method in this case. That's okay, no problem. But the question is, how do we change the expiration date in case it's a PayPal account? As I discussed before, there is no expiration date inside of a PayPal account. And the problem here is that we need to return a payment method because we are within a copy function. So here, really, we have no choice. We have to return something of type payment method. So you could argue that you could throw an exception. You could say, okay, impossible to change a user with a PayPal account. That's one way to do it. But in FP, we try to avoid throwing exceptions. So another way to solve this problem is to say, okay, if you try to call update expiry on a user who has a PayPal account, basically it does nothing. It's a no operation. That's depend on your use case, but that's one way to do it. If we want, we could use also other techniques like using an option or an either to figure out if the action really occurred or not. But it will require a significant refactoring. So for now, we just say if you try to modify a user that has no expiration date, it does nothing, which is potentially fine. Okay. And as I will show you how it works. So let's say you call update expiry with Julian, you see that the expiry date has been changed. But if you call update expiry with Anna, who has a PayPal account, basically nothing happened. You get back the same object. Okay? Does it make sense? Are you okay with the syntax? It's not. Yeah? Okay. Cool. So still, so it's a bit more verbose now, but it's still not the end of the world. So now I'm going to slightly complexify this example. So imagine your boss come back to you and say, you know what? We cannot change our mind. Now, in our application, we don't want to have a single payment method. We want to offer the user to enter several payment methods. So for example, a user can enter several debit cards, several PayPal accounts. And in order to differentiate between the different kind of payment methods, we allow them to put a string, to put a message to say, okay, this is my, for example, my business payment method, or this is my personal payment method, for example. So you're like, okay, that's fine. It's relatively easy to change my model. I will say, okay, now a user has a map string to payment method. So the string will represent the keyword that the user select for this particular payment method. And then the user can say, okay, for example, Julian has a business payment method that is a PayPal account and a personal payment method that is a debit card. Okay, so it's a bit more complex, but still, not extremely complex model. I bet that you have this kind of objects in your data, in your code base. So now the question is, how do we change, again, the expiry date for the personal payment method? So let's try again. So now you should start to know the drill. So we'll do the same thing, except that now payment method is a map. So we need to use the method get on a map and we specify the name of the payment method. And now we have three cases. So this, in Scala, it returns an option. So I don't know if you're familiar with an option. It's basically nothing or something. So nothing is a none and something is a sum. So here, basically what it says is that there are three cases. Either there is no payment method with this name, in this case you get a none, or you have a payment method and it's a PayPal account, or you have a payment method and it's a debit card. So you have three cases. Before we had two, now we have three. And for the same reason as before, basically you say, okay, if you have nothing or a PayPal account, you can't change the expiry date. In these cases, there is no expiry date to update. So you basically return the existing one and you do a no operation. And if it is a debit card, what you do is that you take the existing debit card, you modify it, and then you insert the new debit card inside of the map. So this code, once you're a bit familiar with the Scala syntax, is not extremely complex. But it's very boring. It's very like boilerplate code. You don't, it's not the kind of code that when you're done, you jump out of your chair and you high five your colleagues. Where I've done it. It's boring code that you have to write just to describe how you want to go inside your domain and change some piece of code. And the domain is not that complex, but it's a lot of code. Imagine you receive a pull request with this code. You would have to read carefully each line in order to understand what it does. It's not obvious. So this is where optics come into the picture. So optics are meant to simplify this problem. So an optics, what is it? It's a trait. So in Scala, a trait, if you want, it's an interface like in Java. So it's something like it describes a couple of methods. And it has two type parameters, the source and the target. So if you want, let's take a concrete use case to make things clear. Let's imagine we have an optic called name that the source is a user. So imagine source is a big type, the things you start from, and the target is whatever you're focusing inside your object. And so you have a couple of methods on an object. So you can say, okay, if you do name.get, it will give you back the name of the user. It's fine. You have a method called replace, where you can say, okay, I want to change the name of the user. So you say replace Bob, and this will give you a new user where only the username has changed. Or you can call modify. So modify takes a lambda, so it takes an anonymous function that allows you to modify whatever you're targeting. So it's a convenient method. You can say, I want to uppercase the username, and this will create a new user with the username uppercase, right? So really, it's a very simple interface, get, replace, and modify, that allows you to modify your target inside of an object. Now, if you may have heard of optic in plural, like optics, and you may have heard like crazy names like a lens, optional, traversal, prism, ISO. These are really complex. But in fact, I would say you can ignore these names. They are they are just specific scenarios. They represent specific configuration between a source and a target. I will just give you a quick example. But for example, a lens or an ISO, when you call get, gives you back the target. You're guaranteed to get a target. While a prism and an optional gives you an option of a target because it may fail. It may not be able to extract the data. while a fold and a traversal will give you a list of a target, because you may be able to focusing into several pieces of data inside of your object. But that's the main difference. You can ignore them for now. What matters is that we have this interface with 3 methods. There are concrete classes, but you can ignore these details from now. Now, if optics had only these 3 methods, get, replace, and modify, it would be fairly boring, fairly useless. The things that makes them very interesting, and the fact that they have a method called and then allows you to compose optics, and it allows you to drill down inside of an object. So imagine you have an optic between a source and a target, and another optic between a target and next. You can compose these 2 optics to go from a source to a next. So if you want, it's exactly the same as function composition. And I will illustrate this with a concrete example now. So imagine this, I drew here the representation of our user. So a user is a case class with 3 fields, the name, an address, and a payment method. Payment method is a map with a key, personal or business. The value is either a payment method. The payment method has 2 possibilities. It's either a debit card or a PayPal account. And a debit card is a case class with 3 fields like this. Okay? So if you want, optics allows you to describe a path inside of your object, really the same as XPath or JSON path. And the idea is that every single segment in this path represents an optic. So for example, this payment methods optic is an optic between a user and the field payment methods. And then you use the method and then to compose it, to create a more complex path. So you will say, and then index personal, and this will focus into this particular key. And then you will say, and then debit card, and it will focus into, so payment method is an enumeration. So you will say, okay, I only want to care if the payment method is a debit card. If it's a PayPal account, I do nothing, it's a no operation. And then you say, okay, now that I know that I have a debit card, I want to focus into the field expiration date. So really, optics just describe how to zoom inside of a data structure, 1 layer at a time. So let's compare how you would do this update using vanilla Scala, so Scala from the standard library, or using optics. As you can see, it's not necessarily shorter, but I would argue that once you know what is an optics and you're a bit familiar with the API, I would argue that the optics API is nicer, because here you really describe a path. You say, okay, I want to zoom into the payment method, into this particular key, into this kind of things. And then at the end, once you build the entire path, you say, what do you want to do? I want to replace, to update the expiry. While here, it's really low level. It's kind of, you go down, you remove stuff, you pattern match. It's much more noisy. Now, okay, so now if we agree that, the optics API is nicer, the question is why, not why everyone is not using it, why it's not, why it's not like standard, like if you join a new Scala code base, it's unlikely you will see people using this. Most likely they will use this syntax. So why is that? There are a couple of reasons. So the first one is that historically in Monocle 2, so Monocle 2 is the current version of Monocle, and it's about to be replaced. It's actually much more verbose. So we don't have this method and then, we have several methods like compose optional, compose prism, compose lenses, and each compose method take a different kind of optics. So it's very verbose. If you look at this, the noise that represents the compose function is quite large. Potentially the composition is kind of the glue between optics, and you would want this to be as small as possible. So why did we do this? We could have overloaded the method. Instead of creating different names, in Scala or in most programming languages, you can use overload. You can create different functions with the same name that behave similarly. Well, we didn't do this in Monocle 2 because there was a problem around generic optics. So if you want, I'm not going to go into the details, but if you want, like index allows you to zoom inside of a collection. So you can zoom inside of a map, you can zoom inside of a list, you can zoom inside of vector. It's very generic. It allows you to zoom into any kind of indexable data structure. And this genericity has a cost. It means that we need to use a concept called a type class. And I mean, it's a bit complex, but basically you need to have more work in terms of type inference. So you need the Scala compiler to do more work. And it turns out that the Scala compiler is very weak. It is not as good when you use overloads. So it turns out that for this particular case, it will not compile and it will give a crappy error message. So all our users will be, will have a useless error message and it will be very difficult to understand. So that's why already in Monocle 2, we add these things using non-overloaded functions in order to help the compiler. This was really a workaround, if you want. Now, in Monocle 3, so the new version, what we use is that we use a new technique that is based around a concept called extension methods. So an extension method is not a method you define straight away in the optics class, but rather you define it on the side. And what's nice with this is that you can define like specific patterns. So you can say, okay, if you have an optics from a source and where the target is a map, let's add a method index straight away. So if you want to kind of guide the compiler, instead of doing some kind of complex resolution, you tell it, if you have these specific patterns, then add a method index to the data structure, which means that instead of doing this and then index payment method, you straight away call a method index on the optics. So it's nicer to use for a user, to be honest. And in fact, it's also great for documentation because, one problem with optics, I mean, this optics composition is great. You can compose anything together as long as one end is matching. It's a bit like Lego, as long as you can, stick them together, it's fine, it works. But it's bad in terms of discoverability because you're like, okay, I have my piece of Lego, I have my optics. What should I use next? You're like, I don't know. Normally we have an IDE to tell us, okay, what can I do next? And the nice thing with this approach is that you can use like a better documentation. So now we can write like a Scala doc here. And for example, you see that this is using IntelliJ. You can say that now you can do payment methods.index, and you will see some kind of documentation that explains you what does it do exactly, see some other methods that are related to this for other use cases. So it's really great for users, and I think it's a good change. Now, another big limitation we had is around the second problem we had was around the optics creation. So if you want, this code may look nice, you're like, okay, that's great, I'm going to use this in my own code base. But you do need to create these things, these payment methods, payment name, debit card. They don't come out of the blue. You need to create them. And quite often, when people talk about optics, they're like, say, oh yeah, you create it over there. But it's actually lots of boilerplate. You have to define these guys. And not only you have to define them, but they take lots of code. Like, for example, I will show you, this is the actual code to define the payment method, the debit card, and the expiration date. And you're like, what the fuck? Like, why should I use optics if I need to actually double the boilerplate for my code base? Maybe it's useful if you have a very complex data structure and you want to reuse it many times. It may start to be worth it, but it's annoying. And another thing that is really annoying in this is that you need to say that payment method is a lens, while debit card is a prism. And you're like, imagine if you know nothing about optics, which is probably the case, you're like, how should I know that? How should I know that the relationship between a user and the payment method is a lens, while the relationship between a payment method and a debit card is a prism? You don't know, you don't know about optics. You don't have a PhD in category theory. So it's really annoying. You need to read lots of documentation in order to figure that out. So what we did in Monocle 2 to slightly help with this is that we use macros. So macros is an advanced concept in Scala, which, if you want, it's a way to describe how to generate code. So it's very good when you have boilerplate codes, code that looks always the same, and you want to automate this process. So this is the main use case for macros. And because, as I showed you, like this code for optics looks complex right now, but if you do it like 2 or 3 times, you will know the pattern. It's not clever at all. It's always the same. So this is why we define these macros for users. So they only need like 1 line of code in order to define it. So it's much simpler if you want. Now, still the big issue that we have is that you still need to know that this is a lens, while this is a prism, which you probably don't know. So the idea we have with Monocle 3 is to create one macro to rule them all. So it's like, the most powerful macro that you can get that will generate the right thing for you. And this will really behave like XPath or JSON path. So the idea, we call this macro focus, and you specify, okay, this is the things where I want to start from. So I want to start from a user. And then you describe how do you want to zoom inside this object. So this is a lambda, so it's just a normal function. And what this macro does is that it's going to analyze the code that you wrote. So it's going to analyze that you did like this _.address and say, oh, address is a field of the user and street number is a field of the user. Okay, so in this specific case, I need to generate a length. But if you want, you don't need to know about it. The compiler will tell you for this particular path, this is a length user to int. So you don't need to know about it. The compiler will do all the thing for you. And we added also some extra operators. So for example, there is no method indexed on a map. But what we did is that we used some tricks to guide the code completion. So all of this is out of the blue supported by the IDE. So you don't need to have any specific, quite often with macros, you may have all your code that looks red because the compiler doesn't know really what you're doing. But all of this is perfectly supported by the compiler. The compiler understands perfectly what you do, and your IDE also understands it. So what you do here, for example, you say payment methods.index, and in this case, instead of generating a length, it's going to generate an optional because there may not be, as you remember, I said like an optional is something that encodes the relationship when the data may be missing. So again, you don't need to know about it. The compiler will do the right thing for you. And now you say, okay, I have a payment method, but I want to consider the debit card. So you can add another thing in your path. You can say, as debit card, we'll do a save downcast, and so on. So you can keep going on. You can build a path like a normal function, and the compiler, the library, will build the right thing for you. And so I would like to thank Yillingwei and Ken Scambler, if I pronounce their name correctly, who came up with this idea in Monocle 3. And this will only be available in Scala 3. So Scala 3 is a new major version of Scala that has a completely new implementation for macros. So we can't really do that in Scala 2. This is a new feature that we can only do in Scala 3. But I'm really excited about it because, as you can see, we just describe a path within the data structure. And I think like if you use JSON path or XPath in the past, this, you will most likely be familiar with this kind of path API. But except of, generally JSON path or XPath, it's not typed. So you have no idea really what kind of data you get. But here it's all type safe. It's all known at compile time exactly what you're doing. And it's all supported by the IDE. So you can't even make a typo in the name of a field. The compiler will tell you, is it right or not? And we went even one step further because, as you can see here, it creates an optics, and then you can use the optics on a specific object. But quite often, you just have one use case. You say, okay, I have an object. I just want to modify it. I'm not going to reuse this modification 50 times. I just want to use it like a when you write a script, I'm going to use once and for all. So it's annoying to create an optics this way because you need to give it a name and you're like, okay, how should I call this thing? So what we did is that we created a special syntax where you can say, okay, if I have a user, you can say .focus on this user and then straight away describe the path. So if you want, it's more like an OOP syntax when you say, okay, here is my data, here is the things I want, here's the things I want to target, and then here's the operation I want to do, which I believe is the most natural way we want to make modifications. Cool. Any questions about this? So it's all available in Monocle 3, these sort of things. So I just would like to summarize. So basically, the talk is roughly finished. I just want to summarize what we've seen today. So really, the problem is that modifying immutable data is generally, in all languages that I know, is boilerplatey. It is complex to mutate something immutable, which kind of makes sense. It's not really the main use case. So really, optics is just a new API, a more user-friendly API to modify immutable data. And the main idea behind it is to describe a path within your data structure. And once you have this path, you modify or you access whatever you're targeting. And I really believe that, in the future, next late generation programming languages, they will come with optics. This is in Scala, it's in Haskell, it's in many languages. But I do think that, the standard getters and setters is too limited. I really believe that this is going to be the normal way to modify data in the next 10 years. Programming languages don't evolve that fast, but I really believe this is going to be standard. And to give you some idea about what changed between Monocle 2 and Monocle 3, in Monocle 2, we had lots of boilerplate. We had this macro, but still overall, you needed lots of boilerplate. And the worst is that you require too much knowledge. So if you're a new user of the library, you needed to learn too many things in order to use it. And even if you're familiar with FP, I had many colleagues, you're like, you use the library once every 6 months and you're like, you forget, you don't remember what's a prism and an optional. It's normal, it's not the kind of things, if you don't use them every day, you forget. While in Scala 3, we try to make it much more user-friendly by basically removing all these requirements of knowing all these things up front. And if you want, you can learn about it. But generally, it's the library who tells you, okay, for this particular case, this is what you get. And then you can check, what are the methods I have access with an optional or a prism. So you don't really need to know what is it. You can just use it. And what I'm really excited is this focus macro. I really believe it's going to be a game changer. And so this is available. I just released an RC, so a release candidate, a week ago. So if there is no major bug, within a week or two, you will have access to Monocle 3 in Scala 2.13 and Scala 3. So it's cross-compiled to these two versions, but the focus macro is only available in Scala 3. So we try to make the API as compatible as possible, but you will not get this very nice focus macro in Scala 2. It's just too much work I'm not even sure it's possible. And even if it is possible, it's too much work to make it work there. And I think it's good to motivate people to migrate anyway. So it's a good motivation. It's a good carrot. Cool. So I would like to thank the entire team because, it's not, I get lots of credit generally for Monocle, but I'm just one of the person who contribute to this. And originally Monocle was created from a Haskell library called Haskell Lens that I copied over and changed it to Scala. But many people have worked over the year. I think it's a 7 years old library. And many people have worked over the year in this. And generally, most of the great ideas don't come from me. They come from other people. In particular, Ken Scambler and Yilin Wei that I mentioned, they worked a lot in this focus macro. And to be honest, I would have no clue how to do it myself. And really, if you're motivated, I would really encourage you to come and try to participate. So it's always tricky, you may be afraid that, I don't know anything about optics, but we always have other issues, an open source library, the main code is actually not the biggest problem. You need to have good tests, you need to have good documentations, you need to work around the build, you need to answer to people somewhere. So there's lots of maintenance around it. And to be honest, this is the most annoying part. It's sometimes 95% of our job as a maintainer. So if you want to be helpful, if you want to contribute to the community, if you can come and help us with this task, it's amazing. It's really useful. And if you want to learn optics along the way, we are more than happy to mentor you and help you to learn new things. Okay, so now that I'm done, I just would like to say a quick word about the project that I mentioned at the beginning of this presentation. So it's been 2.5 years that I'm working on this online course called Foundations of Functional Programming in Scala. So the idea of this course is that I wanted to create a course that you can start from scratch. If you know nothing about FP, if you know nothing about Scala, you can pick it up. But it's also good if you have a couple of years of experience. And that focuses into the practical aspect of FP. Because quite often, when you hear talks about functional programming, first, the terminology is complex. You hear about monad, transformers, stuff like this. You have no clue. You feel that you kind of need a PhD in category theory to understand it. And you feel like these people are super clever, like geniuses, but they are not. The terminology is confusing, but you don't necessarily need to talk in this way. So I'm trying to teach FP using simpler terms, using like not a lot of not so complex jargon, but also to focus into the simple part of FP. Because again, if you look at conferences or blog posts, people like to talk about what's complex, like, all this fancy technology, but actually in practice, you don't really use it that much. What's cool is like immutability, pattern matching, using, for example, something that I focus quite a lot is property-based testing, which is a technique to write tests that covers a wider ground. These techniques are not that complex. You can learn them relatively fast, and they're actually very useful in your job. So I'm trying to show people what are the simple things that are really helpful in our job, because I'm a backend developer like you are probably. So if you're interested, I'm organizing a raffle for people who attend this meetup. So I'm offering 2 30-day free licenses to the course. So I will encourage you to send me an email to this email address if you're interested. And tomorrow I will randomize, like I will just select 2 people out of this group and offer you a 30-day free license if you're interested. Cool, so that's it for now. And yeah, if you have any questions, I'm more than happy to take them.
Yeah, thanks, Julian, sharing. I think that actually a lot of insight, and I think especially think that Julian omitted some very detailed things. But although they may be the most interesting things also. So but anyway, as usual, we will have time for Q&A. And before that, as an organizer, I would like to invite you to fill the past event form. I passed in the chat. There's a link. And if you have any opinion or question or issues about our event, please just fill this form. And yeah, sorry.
Can I mention one thing? I just forgot about the course.
Yeah,
I would like,
please.
is that the course has also subtitles, so in English, but also in different languages. And it's actually the first 2 chapters are subtitled in Japanese. So there is Kondo-san and Tanabe-san that might be in the meetup today that did all the work to translating the subtitles. So if you have some colleagues that may not be that familiar with English, at least the first 2 chapters and maybe more later are subtitled in Japanese. And so I would like to thank them for all this work that they did.
Okay, thank you. And for Q&A, if anyone has any question, you can just unmute and briefly introduce yourself and ask the question, or you can raise hand or type in the chat. That any way is okay. Yeah. So I got some question, but I think I better to let attendees join. So yeah. Any question? I think people asked me in private channel about whether optics is the Scala only thing.
No,
I found that actually Haskell has that library. And
it came from Haskell. So it came from a Haskell, and it really went. It's kind of like a virus a bit, like so. I copied in Scala. Other like Java, Kotlin, even TypeScript copied from Monocle. So you have like kind of like this. The original idea came from Haskell, and to be honest, it's not that long ago. Like I think it was like it didn't really exist. I think 15 years ago. So it's relatively recent. And the recent idea,
right?
And yeah, so now it exists in many languages, but I do think that it's going to be more and more first class as it comes. Like,
yeah, I was actually asking Greg because I'm mainly working with Elm, and I'm wondering, in Elm, do you guys use any kind of optics libraries, or because I think the building way to change an immutable record is still a bit verbose. Right.
There might be an Elm library. I don't know Elm that much, but I imagine there must be one. It might not be like production ready, but I'm pretty sure someone like at least prototyped it.
Yeah. Oh, but I got another question for you. I'm wondering, it looks like to mutate values, it does cost a lot to write your code compared with like other languages, but it gives you more sense of secure. And I'm wondering when for those non-functional programming language, people probably using unit test to catch those errors. And so my question is, in Scala, do you still write unit test, or because?
Oh, yeah, sure.
Yeah.
Yeah, I mean, I think like, for me, I really like unit test as a way of documentation, not so much as a way of testing. Like it's more like, instead of writing a comment, I would rather use a unit test to show like, okay, for this particular input, I expect this particular output. It's good, to see like, it generally clearly express, what is going on, what is the main use case for this function. The main problem with unit tests is that it doesn't cover too much ground. Like if you have several inputs, and you have like all the corner cases, it's always tricky to do. So what I like to do is a couple of unit tests just to describe what are the most common scenario, like as I said, for documentation purposes. But what I really use for, if I want to have something that I'm really sure about the behavior, you can use the type system. The type system can guide you quite a lot. But also property-based testing, which is, in my opinion, amazing to use for that. So one thing, and property-based testing, it's a different way to think. Like, like quite often, the biggest issue with property-based testing is that you might want to duplicate the logic in your test. And this is like one of the biggest issues that you have when you start writing PBT. So that's why I'm trying to do in the course. I probably spend like 5 or 6 hours talking about how to use PBT in different like real world scenarios. So for example, how to test, you want to check that a parallel implementation gives you the same result as a sequential implementation. Or you want to say that, if you have some kind of inputs for this, for example, if you don't care about the orders, you can express it. You can say, okay, if I randomize the input, if I have one input, I call my function, it works. You say, okay, if I randomize my input and I call it again, I expect to get back the same result.
Thanks. Well, you were mentioning about PVD. I'm not familiar with this term. Like, what's that?
Yeah, it's called property-based testing. Don't know if I will manage.
I think Haskell has a library called QuickShift.
It has several libraries.
Yeah.
So actually, if you don't mind, I can show you a couple of examples if you're interested. Because I was preparing anyway some kind of demo for my course.
Well, meanwhile, we have another question. So yeah.
So just like to show you quickly, imagine you have this is a very common testing strategy. So imagine you have a function string to int that tries to parse a string into an int. So if it is real numbers, you want to get an int. If it's not a number, you want to get a failure. So something that, it's a none. So you could implement it like this, doesn't really matter, but you basically rely on the toIt implementation from Java, and it may throw an exception. So this code is just say, okay, call toInt and catch the exception. So one PBT you could do is to say, like, it's called a Roundtrip property. So you say, okay, let's generate a random string, any strings so the framework is in charge of selecting the random string for you. And what you describe is you say, okay, if I call my parsing function and I do get a number, so this is, you pattern match on it. So you say, okay, I may get a number or I may not get a number. And you say, okay, if I do get a number, I expect that when I call toString on the number, I get back the same thing as I got as an input. So it's a round trip in a sense that, if you start from something, you do some kind of transformation and you come back to it, you expect to come back exactly to the same thing, right? Well, you say, okay, if the parsing failed, then you can't really say anything. So it's not total, it's not going to cover everything, but at least it covers this particular scenario that you expect this round trip property. And I really like this example because it's something that I actually had to write in Monocle. So I had to write a test like this in Monocle. And it turned out that this test failed after a couple of months. So I will show you the error message that I got, and it's just really funny. So I got this error message after a couple of months on CI. So it told me that the number 9 did not equal this. And you can imagine my face when I saw this error message, like what the fuck? Like, what is this? And it turned out that this symbol is actually the number 9 in some kind of languages from Southeast Asia. And if you call 2int on this string, you do get the number 9 in the Java language. So, you have to, I bet that, if you can ask like any kind of Java expert in the world, no one knows this thing, like, at least not many people know about it. Probably you don't care, to be honest, it's just an anecdote, it's just funny. But it's just the thing that, it's very difficult for a human to write good corner case example, because you just don't know what you don't know. So this is where property-based testing is good, because it allows you to find scenarios like this that you will never find on your own.
I see. Thank you.
Yeah, thanks, Julian. And for property tests, I only have one thing to say is I heard that it's difficult to find the property to test. The proper property to test is the most difficulty. Yeah, to choose.
Yeah, but it is difficult, but it makes testing more enjoyable, in a sense that quite often you write the code, or it depends if you do TDD or not, but quite often you write the function and you're like, oh fuck, I need to write a test for it, and you're like, oh, maybe I don't need it, it's quite obvious, or something like this. We like to talk ourselves into say, oh, it's okay, I don't need to write a test. And so property-based testing makes it a bit more like, you're like, oh, let's try to find a great property about this thing. It makes it a bit more exciting. So, I think like, you kind of need to gamify a bit against ourselves, because we are all lazy. Most of us are lazy. So it's good to have a way to kind of motivate ourselves to write good tests.
Okay, we have a question in chat. So it's from Sad Hasmi. Pardon me if I pronounce it wrong. It's about, does Monocle provide declarative optics? You can see it in chat as well.
Yeah. I'm not sure what does it mean exactly, declarative optics. If you have an example or something.
Okay. Maybe Zoom cannot pin someone, so. Well,
but if you have an example later on, I'm happy to answer.
Yeah, please just type in the chat later if there's any information provided for that question. Meanwhile, anyone got any question? I got actually one when I tried to when I was listening to Julian's sharing, I remember that once I tried free monet in Haskell, it's more like everything could be AST, and you can traverse it and make your interpreter for the AST. Sure. It's called free. I don't know whether like Monocle or optics is also can be used like that. It's more like bring the side effect to a traversing, right?
Yeah, so I do know that in Haskell, they tend to use optics for a lot of things. Like, for example, if you have a web API, like a web server, they may use optics to set, for example, the different headers, or to access, to parse some of the data. But to be honest, I really see it as just, when you have complex data or complex-ish data, it's great. So one thing we're trying to do in Monocle 3 is to, because the problem is that you're like, okay, if I have very complex data, you understand the benefit of optics, but generally the boilerplate or the cost of learning it is a bit too high that for simple use case, you're not use it. So we are trying to lower this entry barrier. And so, for example, this is an example from Monocle 3. And as you can see, so this is a standard example with a user. This is how you want to set the name. So it's not, it's not the shortest things you can come up in the world, but I do think it's short enough that, it can motivate people to use it, even if they have a very simple use case. So but I think from that, you could use it for more complex scenario. But I think that the biggest issue we had was the fact that only people would use it when they had complex data structures. But now we are trying to lower this entry barrier.
Yeah, actually, I think with macro, it's pretty elegant enough. I come from M word, and there's no such things. Everything you need to type a very long, some kind of verbal string to transfer data. So actually, I think macro. Some people hate macro just because C and maybe C purpose get the wrong design about what a macro should be. But when you get to the right place, it could be powerful and elegant actually.
Yeah, I think it depends, because the problem is that it's magical. So it's like, you don't really, you can't, just look up the code and see what's happening. You can offer, but I do prefer, if you can do something with normal code, I would say it's better.
Yeah.
But when it's really boilerplate, I think macros are great when you have lots of boilerplate, stupid code that you just want to simplify. Like, in this case, is something that, what I imagine programming, how it will be in the future, is that, when I say future, is like a couple of decades from now, is that, we kind of have a compiler that will be an assistant to us, like that will say, you describe what you want to do, you are the programmers, you know what you want to do, you know how you want to do it, but the specific details, the compiler will implement, the assistant will work the code for you, will do like most of these things. And I don't know if you know a language called Idris, and it starts to be a bit in this way, where you write the signature, and in couple of cases, you can ask the IDE to implement the function for you. And if it can't, sometimes it can implement it completely on its own, but sometimes you just have to guide it. So you say, okay, oh, can you please try to do a pattern match? Okay, so in this branch, it should be obvious, do it for me. And in this branch, so it's more like a discussion between an assistant that do all the stupid things, I mean, all the obvious things, and you who has the main knowledge.
Yeah, that's because they have a very powerful, and they're really focusing on like a searching problem. You can actually code the searching problem because you try to search a function fit what the signature you define. So yeah, that's really amazing. But I think Idris in Scala is totally, I mean, it's not totally different, but what they focus is different. So yeah, I don't know if Scala can easily adapt the idea. Yeah.
I don't think so. But I think it's very much research at the moment. I don't think we are really close to make it mainstream. It's still very complex to describe all these things. It's good that some languages try it out. Like there are so many things to explore. In a sense, I'm a bit sad when I see languages like Go, or that there are new languages, but there is not much new.
That's true. Pretty true.
It's like Rust, for example. It's amazing. It's very interesting that they bring stuff from bring new ideas to the lower level programming, like to replace C and C++ in much better way. So I think that the space is so big. There's so much things we can try. So.
Yeah, but actually, I was working for Mozilla, and I know a lot of time. If you're working for Mozilla for a while, the C props they wrote is actually more like Rust without the compiler and the language infrastructure. So they already writing Rust a lot of time, but although it's still C props. And for Golang, personally, I feel it's used because you can quickly get some prototype without writing too many tests. With dynamic language, you will, you create a full gun every day without compiler. So Go is at least better than that, but still you get a neo pointer insertion every time. Like I say, it's not new actually. Just become a safer language with neo insertion maybe. Because I work now writing Go every day, so I kind of feel like that. The only thing make it better is at least you can GDB into that. So you can use the older way to solve the new languages bug. Well, nothing changed, I believe. Yeah. Oh, yeah, by the way, I have another question for Julian. When the Monocle or Optics encounter the Java data structure, how is it like a smooth handling way, or maybe some bumping place?
It's a good question. To be honest, I don't know. I mean, yeah, I don't know. It was a good, it was a big selling point of Scala to interface with Java historically, yeah. But now the Scala code I wrote for the last couple of years is fairly rare that I do interact with it. Like, I mean, you may do it on some, on the how do you say, like on the edges, like for example, if you want to interact with CSV or not CSV, like Excel or something like this, you may use the Java libraries but I wouldn't say it's something you do very often. And at least in the use case I had, I never really used Java. So I don't know. I imagine it will work, but you would definitely not get the nice focus macro to work because it does need to have case classes and enumeration.
Yeah. Okay. Still thinking, and I believe that's why Scala. Sometimes people like Scala because you can easy to interact with all the code and all the things. So yeah, that could be.
I think it was a great argument for like at the beginning, and it's still good, you know, for like when you get a new database or something like the new driver, you don't have to implement it yourself. But sure. More and more, like I think the community now is big enough that it's not that I mean, you don't really need Java much nowadays.
Yeah.
I also have another questions related to the memory usage of Scala, because yeah, it's like other functional programming languages, right? We use immutable data everywhere. I know there's some technique like share the data structure or like lazy loading or things like that to save the memory. But at the same time, we also increase the use of memory. Overall, like comparing with other languages, what's the memory usage? Things like
I don't have a benchmark, but in practice, it has rarely been a problem in all projects I work. So I imagine that there is probably more memory, more garbage collection going on. But in the garbage collection, I've been improving over the years. So you basically don't really need to change your code and don't even need to work on Scala. Just the garbage collector, there is different algorithms that are released every couple of years that gets better and better. So I don't, it's rarely an issue. I mean, yeah.
I see. Understood.
Yeah, usually compared to that, actually the leak memory and the race conditioning, because of using multiple structure, get more problems.
Yeah, I think like, I don't think there is a silver bullet. Like, if you want to something super efficient, something that has low memory footprint and starts very fast, I would use Rust, for example. I don't think Scala will be the great choice for this. But if you want to have I think the problem is that, most people, the thing that is easier to measure is like performance, how fast is it, or how much memory does it use? This is easy to measure. So we talk a lot about this. But to be honest, in most projects I've worked, you're like, the business wants it to work and they don't care so much, like, is it like, is it 100 milliseconds or 150 milliseconds? It's like most of the time it doesn't really matter. So I think like if you can write code, and also the thing that nowadays developers are really expensive comparing to actually the metal, like, comparing to like, if you can spin up another box in order to make it to palliate for the slightly less efficiency, it's much cheaper than the one developer salary or 5 developer salaries over the years. So I think it's always a trade-off. It depends what you do, but I do think that quite often we focus in the wrong thing. I like to think the analogy is like if you pick up a Formula One or a Ferrari to go for the grocery shopping, like, like quite often we try to find the fastest, the most powerful implementation to do something that actually doesn't need this. It's like it's better to have something that is simple to develop, simple to evolve, than something crazy efficient.
That's true.
Yeah, usually I found that in most of the cases you can use like immutable structure. That's good. And if you really need performance, you can, like Haskell, they have unsafe. You can do everything you want for the performance for the edge case, maybe just 1% of your code. I think that's a good actually balance. You don't need to like have unsafe as a default, so you will create a full gun every day and shoot on your feet. But meanwhile, in the most of the cases, you have the safe guarantee, and if you really need that, you have unsafe as the last way you can work around these things. Yeah.
But I think,
and
like,
even don't touch the unsafe, you have like a mutable monad, of course. I mean, yeah. Sorry.
Where FE really is great is, like for example, stuff like, concurrency. It is notoriously difficult to get it right, and you get so many bugs around it. your implementation might be really good, but if it only works on one CPU, it's useless nowadays. So if you can leverage really fully all CPUs, it's better to make them 10% less efficient, but use all of them than use only one but at 100%. So it's always like I think it's better to write code that is easy to get right and easy to release fast, because quite often businesses, they say, okay, it's time to market. That is one of the most important things. Like, are you able to release these new features in a week or two, or instead of taking 6 months or 2 years? And I think this is where type safety and functional programming are great.
I'm just curious about whether there's any difficulty when you and the developer team of Monocle try to debug in the macro generated code or something like that. Is it very smooth?
I don't work too much in this area, so I think, to be honest, I don't really understand what they're doing. I mean, I have a general idea, but not so much.
That's okay. Sorry, I asked the wrong question. Sorry.
No, but yeah, especially I do find macro code quite difficult to understand, and because there are a couple of people that are really interested, I'm happy to delegate.
Okay. Whether we have any new question or no? I think that's pretty much what we have.
Cool, but don't hesitate if you want to ping me later. I'm more than happy. We also have a Gitter channel for Monocle.
Yeah, sure.
So yeah, don't hesitate also to drop me an email.
Yeah, and Julian, you can upload the materials you want on the event page later. Yeah.
Okay. Yeah.
Yeah. Is it okay? If there's no any question and no discussion, maybe we can close this event. About how you feel?
Yeah, sounds good to me.
Okay. And this is someone is pinging.
Oh, but thank you everyone for attending. I really appreciate it.
Yeah, and then thank you very much. Yeah, enjoy your day. Thank you.
Thank you, Julian. Bye.